Okay. So now you want to know more about it. I think you should actually go through this article. This is an open access article, and you will be able to download without any restriction. This is biomedical research in developing countries, opportunities, methods, and challenges. Now, when we talk about doing a study or undertaking a study, you have to understand that it has multiple steps. The first step is conceptualizing the study. The second step is designing the study. And third step is funding. Fourth is study execution. Fifth is paper publishing. And sixth is improving or increasing the impact of the study. So what happens is, I have left behind deliberately here the designing of the study, because the next 50 minutes, I'm going to talk about how to design a study and what are the types of studies. Now, last time I spoke about the research question. And when we talk about conceptualization, this is actually asking a good research question. When it talks about funding, that include designing a study, because if you do not design a study well, it is unlikely that any funding agency would be interested to fund your study. Obviously, you need communication skill for your study to be funded, and you need networking so that you know which time, which funding agency is going to open the study proposal and so on. When we talk about execution, we require managerial capability. We require ability to make team and giving a leadership to the team. We require ability to manage the fund. Now, this data analysis paper writing will be done subsequently. Now, when you have to design a study, really, it will depend upon what type of study you are planning to undertake. For example, let us say we are undertaking an epidemiological study. Now, we all know epidemiology is the fundamental science of public health. That means how well the population is or how sick the population is, that we understand from the epidemiological studies. And that helps us to actually know the disease burden. For example, if a disease is very, very rare in a population, then probably putting a lot of attention to that particular disease, trying to prevent that disease, or trying to develop strategies to treat that disease or diagnose that disease is not a great idea, because that disease is not common in that population. That we call as disease burden. Okay. Now, epidemiology is the study of distribution, determinant of health-related states or event in a specified population, and the application of this study to control of health problems. So what is epidemiology? Epidemiology talks about distribution of the disease, determinants of the disease in a population, and that ultimately helps us to control those problems of the population. For example, when we talk about distribution, this is typically called descriptive epidemiology. That means you are trying to know whether a disease is frequent or a disease is infrequent in that population. Second is you are trying to know determinants of those diseases. So the determinant, this is called analytic epidemiology. So distribution is descriptive epidemiology. Determinant is analytic epidemiology. For example, let us say you found the disease is common in the population. Now you want to know, why is this disease common in the population? What are the factors causing this? So this is analytic epidemiology. Descriptive epidemiology helps you to know the burden of the disease, whereas analytic epidemiology helps you to actually know what are the factors which are causing this disease, and therefore you can develop strategies to control it. For example, let us say coronavirus pandemic is going on. So we want to know how common is COVID-19 in population of India. So you find, yes, it is there. Now you want to know how common is COVID-19 in the population of New Zealand, and you found that it is not there. Now you want to know what are the factors which is leading to or which are associated with having COVID-19 in the Indian population, and what are the factors that is helping to prevent or protect New Zealand population from COVID-19. So this is analytic epidemiology. Through analytic epidemiology, you learn that what are the factors which we can control so that the disease burden gets reduced. Now, let me talk about types of studies again. Descriptive studies include case report, case series, and descriptive epidemiology, which I have already talked about. Whereas analytic studies include analytic epidemiology, case control studies, cohort studies, before and after intervention studies, and the randomized controlled trial, and even analytic epidemiology. So these are the study design. So when you are trying to design a study, you should introspect what are you going to actually, what type of study are you going to undertake? So depending upon what type of study you are trying to undertake, you should write the design. Now, you see that I told you here the case report. Now, when you want to, let us say, do a study on one case or on a group of cases, try to understand that this will not have much impact. Like a new case to you may be very interesting, but the same case to another person, a senior person, may not be interesting. For example, today you see a new patient of a particular disease. To you, it will be very, very interesting. You'll say, oh, for the first time I found this disease in a patient, and it was very interesting how I suspected this disease, how I worked up the patient, and therefore you will be very passionate about trying to report that case to the literature. But a senior person, for example, a reviewer or an editor, when he looks at it, he will say, oh, I have seen hundreds of such patients. So therefore, what is new in it? And therefore, your paper will be immediately rejected. So therefore, I would say that whether you do a case report or you do a case series, typically or classically, you have to really spend your time on energy on this. So therefore, it is better to spend time on energy on something which is more likely to be fruitful than spending time on energy on something which is less likely to be accepted by others. So therefore, I will strongly discourage putting too much effort on writing case report or case series. These are weakest studies that are there in the literature. Now, this is the pyramid that tells you which are the studies of which are the study types and which are strong studies, which are weak studies. For example, typically in vitro studies, which most of our PhD students would be sort of doing, unfortunately are not the strong studies. Animal studies similarly are weak studies. Review article, case report, case series, they are weak studies. Whereas case control studies, cohort studies, randomized control trial, meta-analysis, these are very strong studies. So therefore, if you are trying to put energy and effort on undertaking a study, it is better to spend time and energy on the later 3 or 4 types of studies rather than in the bottom of the pyramid. Let us come to the descriptive study. This already I have said. So what are the timeline of studies? The timeline of studies can be prospective study or retrospective study. And I tell you, in our journal or many other journals, we get a lot of submission in which authors claim that this study is prospective. Okay, the authors claim that this study is prospective. We ask a single question, or reviewer asks a single question. Did you take ethics clearance? Suppose if you took ethics clearance and after that study began, then it is a prospective study. But if you did not take an ethics clearance before the beginning of study, but let us say after the study is over, you took an ethics committee waiver or clearance, this is a retrospective study. So what happens is, this is very, very important to understand. That means we might have done a study prospectively, but we did not have a clear aim, and we kept on recording data on standard pro forma, and then one day finally we want to analyze this data. This is typically a retrospective study. Prospective study means you designed the study, you had clear aim of the study before you began the study. What is the advantage there? Advantage there is if you know which question you want to ask from the patient or ask to the patient. If you know beforehand, it is more likely that you would have asked those questions carefully, recorded those data carefully. If you are trying to derive information from the case sheets or case file, now it is possible that all those information, those are there in the case sheet and case file, might not have been properly collected in a retrospective study. So therefore, the prospective study and retrospective study can be clearly made out by the reviewer. Obviously, prospective study are stronger studies than retrospective studies. So prospective studies are the one which you should be planning than retrospective study. Now, retrospective study means study has begun long before. Let us say you joined a medical college today, you are working as an assistant professor. And what happened is today you joined and you want to know the data of diabetes insipidus patient who came to this hospital during last 10 years, even before you joined. This is typically a retrospective study. The data might have been collected very carefully by your boss, but still this is a retrospective study. Whereas in the prospective study means now as an assistant professor, after joining a college, you are beginning a study, you are taking an ethics clearance. Maybe if it is a prospective randomized study, you would even register in a clinical trial site. For example, typically clinical trial gov is the site which we typically register our studies. Now, these registration nowadays have become quite mandatory for many of the studies, particularly the randomized controlled trial, to know that what you wrote in the design before you began the study and what actually you wrote when you are analyzing the data and writing the paper. Okay, so these are timelines of the study. So I'll skip this. So study designs sequence, I told you last time when we talked about research question. So descriptive study or any study you want to take up, you first develop a hypothesis. Now hypothesis already we told you last time that is basically hypothesis is the one which lead to a study question. So you first develop the hypothesis. Case control study, you are trying to investigate the relationship to the outcome. So in descriptive study, let us say my hypothesis is how common is coronavirus disease in Uttar Pradesh now? So this is my hypothesis. So I have to design the study accordingly. Whereas when I do case control study, I want to see how common and how severe is coronavirus disease among healthcare professionals and among the patient coming from community. So in the first case, I'm trying to see the disease burden of coronavirus disease 19 in Uttar Pradesh. So this is a epidemiological study. Typically, it is descriptive epidemiology. Now we want to see how common and how severe is coronavirus disease among healthcare professionals working in SGPGI, let us say, and among patients with coronavirus disease coming from community. So this is a case control design. Now, cohort study is, let us say, how common is the coronavirus disease development among people who have antibody against the virus during next 1 year. So this is a cohort study. That means this cohort study, we want to see all the people who have coronavirus disease antibody in their serum. Now we want to follow them up during the next 6 months. Now we want to see how commonly do they develop COVID-19 during follow-up. So this is a cohort study. And randomized control trial, we will take a separate session on that. So therefore, today I will not talk in great detail on randomized control trial. Typically, some people will call it clinical trial, which is not a great term. It should be called as randomized control trial. So when I'm asking me the first question is how common is the coronavirus disease among people in the state of Uttar Pradesh? Now let us say you have to understand that you are talking about Uttar Pradesh. So Uttar Pradesh is a huge state, large number of population. Now it is not possible that whole of the population you will be able to study. It is not possible that the whole of the population you will be able to study. So therefore, what you do is you will select only a group of people from Uttar Pradesh and do the study. So these people whom you are going to study is called the sample. So you are going to study the sample, a group of people from Uttar Pradesh, and now you are actually going to extrapolate that whatever is the prevalence of the disease that I found in that sample is applicable to the total population of Uttar Pradesh. Okay, even some people can do a study and they found, let us say, 6% of the sample have COVID-19. 6% of the sample population have COVID-19. Now, what he may do is he can take the whole of the Uttar Pradesh population from one of the census and he can mathematically tell that now if I found that among 5,000 or 10,000 people that I have studied, if 6% have COVID-19, that means in the total Uttar Pradesh, in this huge population, I can mathematically calculate what is the burden of coronavirus disease in Uttar Pradesh. But it is very important to understand that your sample should be representative of Uttar Pradesh. Your sample should be representative of Uttar Pradesh. Because if your sample is not representative of Uttar Pradesh, what will happen is that you may underestimate the burden of the disease in Uttar Pradesh, or you may overestimate the burden of the disease in Uttar Pradesh. That's why what people have to do is they have to actually do a sampling. And sampling is typically done using statistical methodology so that they look at what is the total population of Uttar Pradesh, what will be the power of a given sample that you want to study to represent the whole population of Uttar Pradesh. Also, the sample that you are going to study should be randomly selected from the whole Uttar Pradesh, that is statistically done. For example, random cluster sampling. So you randomly select some clusters from different region, and your hypothesis is that the sample that I took is representative of the total population. Now, if you are erroneous there, then you get sample error in the a statistical error. For example, there are two types of statistical error. Type 1 error is also called alpha error. Type 2 error is also called beta error. What is type 1 error? Type 1 error means, let us say we are talking about a case control study. Let us forget about that population study. We are doing a case control study. Case control study means, let us say we are looking at how severe is coronavirus disease among healthcare workers compared to how severe is the coronavirus disease among the community people. Now, what happens is, let us say, truly speaking, healthcare workers get a more severe coronavirus disease. For example, now statistics shows, I don't know whether it is right or wrong, whether there are error in this data or not, but forget about all those for the time being. It shows that maybe healthcare workers develop more severe disease and may die more often than community people. Now, what happens is, let us say truly the hypothesis that we have generated that healthcare workers have more severe disease than the community sample is, let us say, correct. Now, you did a small sample size healthcare worker, let us say 50 people among healthcare professionals and 50 community subjects. And you found there is no difference in the severity. So you found there is no difference of severity or in severity, studying a small population, and this is called type 2 error. So what is type 2 error? Type 2 error means, though truly speaking, there is a difference. Type 2 error means though the hypothesis that healthcare workers develop more severe disease is correct, but in your study, you found it to be incorrect. And this is because of a small sample size. And this is called type 2 error or beta error. On the other hand, there could be another situation, which is small sample size gave rise to an erroneous statistically significant p-value. Small sample size gave rise to an erroneous statistically significant p-value, though in real sense, in a large study, it was not significant. So this is type 1 error. So type 1 error means you falsely discovered that your hypothesis is correct. So falsely you discovered that your hypothesis is correct. Hello? Nee, I'm now in a class, maybe 1 hour later. Okay. So type 1 error means that there is no difference, truly, but you found a difference. And this difference is due to small sample size. This difference is due to small sample size. On the other hand, type 2 error means that truly there is a difference, but you found there is no difference because of a small sample size. This is called type 2 error. So type 2 error means falsely you are concluding that there is no difference, but there is a difference. And type 1 error means falsely you are concluding that there is a difference, though in true sense there is no difference. Now, what is power of the study? Power of the study means 1 minus beta. 1 minus beta means type 2 error. So when type 2 error is less than 20%, the power is 80%. When type 2 error is less than 20%, then power is more than 80%. And minimum power required for any good study is 80%. Minimum power required for any good study is 80%. Okay, I will show you at the end how we calculate sample size using a P-info. I found this computer doesn't have a P-info. Now, second thing that we talk about is many people confuse prevalence and incidence. Many people confuse prevalence and the incidence. What is prevalence? Prevalence means, let us come here. I'll go to an example and then show you prevalence and incidence. This is a study that we did. What we did is we wanted to know how frequent is functional gastrointestinal disorder, for example, IBS, in rural population of Uttar Pradesh. So we wanted to know how frequent is functional gastrointestinal disorder, for example, IBS, in a rural population of Uttar Pradesh. So what we did is typically we went to a village. The village is at Jaunpur, rather 4 villages. We went to 4 villages which are situated very close to each other in Jaunpur district of Uttar Pradesh. And this is our some of the study visit photographs. So what we did is we are going to study these 4 villages and we are trying to say these villages represent the rural population of Uttar Pradesh. Obviously, this is a presumption. We may be correct or we may be wrong. But what happens is you have to include most of the people. If you include very few people, it will be erroneous. Whatever data you will get, the data may be erroneous. You may underestimate the frequency, you may overestimate the frequency. In this particular study, we did not do any sampling. For example, random cluster sampling. Why did we not do random sampling? The reason is when you have a huge population and you cannot study the whole population, because if you remember that word finer, finer means when you ask a research question, we have to remember finer. Finer, F is feasible, I is interesting, N is novel, E is ethical, and R is relevant. So if, let us say, in these 4 villages, total population would be 5 lakh, then it would not be F, that means feasible. But in that case, out of 5 lakh, we would random cluster sampling will do, and we select, let us say, 5,000 of these 5 lakh. So this 5,000 should be representative of 5 lakh. It cannot be a skewed sample. But in our case, what we did is we went to the census of India. So this is available at http://censusindia.gov.in. So we went to census of India. And the census of India told us that in these 4 villages, we have 5,415 people. 5,415 people. Then from the census, we tried to find out who are the adults, because our aim was to study the frequency or the burden of functional gastrointestinal disorder in adult population. We did not want to study the pediatric population. So from the census we got total 3,426 adults are living in these villages. So what we did is we did multiple meetings with the villagers in the schools there, and we organized educational activity, motivational activity to motivate them to participate in this survey. Now, fortunately, participation rate was very high. 93% participated in our survey. So of 3,426 people, 3,174 participate. So now this question that the study sample does not represent the study population, that is 4 villages, is gone. This doesn't apply to us. Okay. Now, total number participating. Okay, so this is, actually number of subjects whom we wanted to survey. This is whom we wanted to survey. Now, but we went to survey them, 3,174. We got 2,876 participating. So we excluded 102 out of this because of inadequate data, and we got 2,774 participants in the final analysis. So what does it tell you? Our population sample was almost 80% of those people living there, adult people. Therefore, we are reasonably sure that the burden of the disease that we found in those 4 villages actually represent the population. Okay. Now, what happens is, so now what is this? What we found, is it prevalence? Is it incidence? This is prevalence. Unfortunately, we get paper written in the journal and submitted to the journal where the term incidence is used there. It is wrong. What is prevalence? Prevalence is typically point prevalence. Point prevalence means number of people with disease and number of population at risk. So here, population at risk is 2,774. 2,774, they are the population. Now, what is the number who have this disease into 100 is prevalence. This is not incidence. What is incidence? Now, if you have to find out the incidence, what you have to do is that all those who had the disease during initial survey, you exclude them, because if they have the disease already, they cannot have development of new disease of that nature. So you exclude them. After excluding, you follow up all those who did not have this disease during the initial study, let us say 1 year later. So it will be new disease occurrence in 1 year in those people who did not have this disease earlier is called incidence. It is very important to understand these two terminology. You know why? Because people do hospital study and they talk about incidence and prevalence. In a hospital-based study, let us say in outpatient, you have not even selected all the people who are coming. Maybe you have selected only a few, and then you studied them, and you talk about prevalence is absolutely wrong. So there we use a loose term. This is called frequency. So you have to keep all this in mind in designing the study, and what helps us to design this study. Look at this. This is a study design which was written before even we went to survey these people. So this is what is called designing an epidemiological study. Now here one thing can be wrong. Anybody can tell us that these 4 villages in Uttar Pradesh, do they really represent all the rural population of Uttar Pradesh? Yes, that is an assumption that we think we may be right. The assumption can be absolutely wrong. Now let us come to the cross-sectional study that we already showed. I think I'll skip this cross-sectional study. Let us come to the case control study. Case control studies are very easy to do compared to epidemiological study. You know, epidemiological study, you have to go to the community, which is not an easy job. Whereas typically, if anybody is interested to do an MD thesis or DM project, or somebody who is doing a PhD, now you want to do a study among the of a molecular mechanism or phenomena in a group of patients and group of healthy control, this is called case control study. Okay. Now in case control study, you are actually comparing a phenomena among a group of people who have the disease and the same phenomena among a group of healthy control who do not have the disease. Okay. So basically, this is an easier study to do. Now, when you do case control study, let us take an example. Let us say I'm doing a study on Helicobacter pylori frequency among stomach cancer. Let us say my hypothesis is Helicobacter pylori may cause or may be associated with stomach cancer. So what I have to do, my design I want is a case control design. Case control design means I'll take patient of stomach cancer and I'll take control population who do not have stomach cancer. Okay. And obviously I am going to do a study among, let us say 100, 200, 300, 400 patients of stomach cancer. Maybe I am going to do 100, 200, 300, 400 control population who do not have stomach cancer. You will say, how do you decide 100, 200, 300 or 400? I'll tell you later. This is called sample size calculation. I'll show you how do you do later. Now, my assumption is all this patient of stomach cancer that I'm including from my hospital is representative of stomach cancer either everywhere in the world or at least in India or maybe Uttar Pradesh. Similarly, the population that I'm recruiting, this is again, that is my assumption. So this is my sample. My assumption is this sample on the right side represent the population of the state or the population of the country or population of the world. So my sample should be powerful enough. That means my power, study power or sample power should be at least 80%. Now the case control study, you are taking the cases, you are taking the control. Now you are looking in the case factor present. On the left side you see factor present, factor absent. That means H. pylori present, H. pylori absent. Similarly, you are seeing in the control factor present, factor absent. That means H. pylori present, H. pylori absent. Obviously, it is like a retrospective cohort study. You know why? Because this factor present and factor absent have happened over a long time. The H. pylori might have been acquired in last 20 years or 30 years or 40 years. But you are doing a cross-sectional study here. So cases and control, you are looking at factor present and factor absent. Now, this is the design of a case control study. Now, let us say we found that among cases, there is a factor present. That means H. pylori is present, let us say in 70% of stomach cancer. Let us say in control, you have 40% H. pylori present. And you will do a statistical analysis. We'll talk about how to do statistical analysis later. We'll do a statistical analysis and calculate the p-value. And if p-value is significant, don't say H. pylori causes stomach cancer, because H. pylori is associated with stomach cancer. So case control studies never talks about causation. They only talk about association. So case control study means H. pylori is more often associated with stomach cancer than control population or healthy population. The association does not prove causation. Now let us come to the cohort study. Let us take this example here. This is an example of cohort study. But before that, let me come here. This is a study that we did. We took actually 198 patients of stomach cancer. We took 101 patients of dyspepsia, which is another group of control. We took 355 healthy subjects and look at their H. pylori, and we found there is no statistically significant difference. And therefore, we concluded H. pylori may not be associated with stomach cancer in Indian population. Okay. Now, I'll talk about nested case control studies. What is nested case control study? Nested case control study means when you study a disease, let us say you study a disease, and let us say the disease is rare. The disease is rare. Now, obviously, when a disease is rare, it is difficult to take a lot of sample or a lot of patients with that disease. But you know, getting control sample is very easy. Now then you can do a design where you can take one patient for 2 control, or one patient for 3 control, or one patient for 4 control. Now, when you do that, what you do is that you take one case, but control may be age and not gender match. Let us say controls are not getting age and gender match. Let us say you do a study over next 1 year on a group of people based on your hypothesis. You did the study, like let us take the example of stomach cancer study. Let us say from today, I start collecting sample of stomach cancer patient. I keep their sera in fridge, and let us say 2 years later, I do their serology. Now, after doing H. pylori serology, now I know in my stomach cancer population, what is the frequency of H. pylori seropositivity. Now I decide that I'll take control. So who will be the control? Maybe healthy control means I'll ask my student, maybe ask my staff member, maybe. Now you got your control sera and you do test for H. pylori. Now when you do test for H. pylori, what is the problem? Look at the problem. Problem is, if I take my staff member, my student, or our colleague, what is the problem there? Problem is we are socio-economically better off than the community sample which is coming to show in SGPGI as stomach cancer patient. Maybe we live in a better environment. Our sanitation is better. Maybe our drinking water is better. Now this influence H. pylori positivity rate. Let us say you took a lot of your students and they are all younger. And we all know that H. pylori seropositivity increases with age. So if you take younger control and older cases, you will get different prevalence of seropositivity of H. pylori. Now, what is the problem there? Problem is you did a case control study and you have already done the study. But you can do a nested case control study now. You say, because we have a lot of samples in our fridge, we collected over time, they are all healthy population. Now, what we'll do is we have all the data of them. Now, for each case, I will take 2 control or 3 control, match for socioeconomic status, match for age, match for gender. So you are nesting, you are making a nest of control. Within this, you are putting a case. So this is called nested case control study. Nested case control study. You are doing that so that your cases actually match with the control. Now let us now come to a cohort study. We come to now a cohort study. Okay, we'll skip this. We'll come to a cohort study. What is a cohort study? Cohort study means we are now trying to, let us take the H. pylori example. Now we say we did a case control study and the case control design suggested that H. pylori may be associated with stomach cancer. Now I want to study in a cohort design. Am I right or am I wrong? So what I have to do? Let us say I take 10,000 people who are H. pylori seropositive today and 10,000 control who are H. pylori seropositive today and follow them up for next 20 years for development of stomach cancer. This is a cohort study. So H. pylori positive 10,000 people, they are all healthy people, but they are others H. pylori positive. 10,000 healthy people who are H. pylori seronegative, followed up for 20 years. And we want to see how often H. pylori seropositive people develop stomach cancer, how often H. pylori seronegative people develop stomach cancer. Now, this is a cohort study. Difficult to do, practically impossible to do. So that's why I take another example, because 20 years, 10,000 is difficult. So I take another example. This is a study that we did. This study, this is a cohort design. Here it is written case control design. Forget about that title. It is a cohort design. So what happens is that when people develop acute infectious gastroenteritis, though many people recover, everybody don't recover. Some people develop post-infection irritable bowel syndrome. What is irritable bowel syndrome? Their bowel become irregular, they have abdominal pain off and on, they have loose stool or they have hard stool, they have mucus with stool. This is called irritable bowel syndrome. So we now know when people develop acute infective gastroenteritis, they don't bother. They say, oh, this is just 3 days phenomena, I'll be okay. Now, 10 to 20% can have long-term consequences. This is called post-infection irritable bowel syndrome. So this is a study that we did in which we took 345 people who came with acute infectious gastroenteritis. 345 people, healthy people, who did not have any problem. Now they were followed up for 1 year. So this is a cohort design. Why cohort design? We have taken them at a point and then followed them up for 1 year. So this is a cohort design. Okay. Now, look at this. Our design was that we'll evaluate these people at the beginning, with a study questionnaire, which is called Functional Gastrointestinal Disorder Study Questionnaire. So you should have a proper questionnaire at the beginning. Don't ask anything that you like, because that will not be a valid question, and the valid questionnaire based data will not be acceptable. Also, we ask them about GHQ 28. What is GHQ 28? General Health Questionnaire 28. General Health Questionnaire. This is a simple question. How are you and all those. We also asked about parameter of acute gastroenteritis. What are parameter of gastroenteritis? How long have they been having gastroenteritis? How many stools are they passing? Whether there is blood in the stool, whether there is fever, all those are parameters of acute gastroenteritis. We did a baseline stool microscopy. We did stool culture, and we also did polymerase chain reaction for E. coli, knowing that stool culture may not always yield what organism caused the acute infective gastroenteritis. Look at the design. That we are saying that healthy control, we ask for EAR3Q, that is Functional GI Disease Questionnaire. We asked for General Health Questionnaire, and we did not ask for parameter of acute gastroenteritis. Okay? So healthy people, we asked for, that's why you see that it is right here, it is right here. Ticked here, ticked here. Now we look at this. baseline stool microscopy culture for PCR for E. coli, acute gastroenteritis patient we had, but healthy people we did not do. We gave routine hospital care to acute gastroenteritis patient, but we did not give to healthy control because healthy control did not come to the hospital. And then we followed them up for ER3Q, these are functional GI disease questionnaire, at 3 months, 6 months, 9 months, 12 months, both acute gastroenteritis patient and healthy control. Look at this. This is how you have to write your design. And the design doesn't take much time. It should not take number of pages. In fact, if I'm doing a study, I'll write the design clearly like this, and then I will paste it in front of my office table, so that whenever I'm doing, I know I don't have missing data. Okay, clear? Now what happens is subsequent part are result, so we don't concentrate on result. This we concentrate on design. This is a cohort design. This is a cohort design. Already I talked about cohort design. I talked about. I think we'll skip this. This already I've showed. I think I will skip this and come to randomized control trial. Randomized control trial is one of the most strong designs. Randomized control trial is one of the most strong design. But obviously, we have a separate session on randomized control trial. Therefore, I will not deliberate on today. Okay. Now let us come to a typical example, or maybe I can skip this. This is also randomized control trial. So now remember one thing. When you design a study, when you write the design, you have to write the design, what you are going to do. Like I showed you that figure of our cohort study on post-infection IBS. But let me tell you that you should write your statistical plan when you are designing a study. You should write your statistical plan when you are designing a study. This is what was told by Andrew Lang. He said he uses statistics like a drunken man uses lamppost for support rather than illumination. He uses statistics like a drunken man uses lamppost. That means a fellow who is drinking, he cannot walk anymore, he cannot stand anymore, but he wants to drink more. So what he does is he catches on the lamppost and keeps on drinking more and more. This is harmful. Statistics should be used for illumination. Illumination means your study statistical plan should be written before your study is begun. I know what some people do is that they collect the data, then they start using different type of tests, and they find whichever test give them significant p-value, they report on that. And this is like drunken man using lamppost. Okay. Now you will say, how will you know that? How will you know that what I did? I tell you, nowadays, most prospective study, you have to register in a clinical trial registry. Most prospective study, you have to register in a clinical trial registry. So typically what reviewer or editor will ask is, he will ask, was this study plan registered in a clinical trial registry? And if you say yes, they will ask, can you give me the number? So you'll give the number. They will actually check what statistical plan you wrote there and what statistical analysis you did now. And from that, he can make out whether you use this lamppost for illumination or whether you use this lamppost for telling a lie or telling something which it may not be true. So question is, that's why I say plan the statistical analysis during designing of the study and write that up. And I tell you, like I remember one of the research study that was submitted to our journal, Indian Journal of Gastroenterology. Now, this was a randomized control trial, but the author did not register in a clinical trial registry. So the reviewer was very upset. So a lot of sort of revision went on because reviewer says we don't like this, we will not allow it to be published. And somehow, as an editor, I went through all the literature. This was an important study, and therefore finally we accepted that particular study. And there was an excuse given by the author why they could not register. But the same group, second time, third time submitted manuscript without registering in the clinical trial registry and similar excuses. What does it mean? This paper outrightly gets rejected. Because nowadays, if you even publish without registration, even the editor can get actually a notice, why did you do this? So therefore, plan the statistical analysis while designing the study. You will say, how will I plan? I'll tell you, we have session on statistical analysis.